We will review the procedures for solving linear inequalities and provide examples. What is a linear inequality? A linear inequality in one variable x is any inequality that can be written in one of the four forms: ax plus b less than c, ax plus b less than or equal to c, ax plus b greater than c, or ax plus b greater than or equal to c, where in any of these a is non-zero. Examples are always helpful. Notice that in these examples, a, b, and c can be positive or negative, and they can be integer, fraction, or decimal. In fact, they can even be irrational. To solve a linear inequality, we apply the properties of inequalities appropriately. Some guidelines can be useful, but guidelines are not hard and fast rules. They are simply suggestions for how to solve the linear inequalities. First, clear any fractions or decimals by multiplying by an appropriate constant on both sides of the inequality. Be careful, though, about multiplying by a negative quantity on an inequality, because you have to remember to reverse the inequality sign. Next, simplify both sides of the inequality by clearing parentheses and collecting like terms. Then collect all the variable terms on one side of the inequality by adding or subtracting the appropriate quantity on both sides. Next, collect all constant terms on the other side of the inequality, again by adding or subtracting as appropriate. Finally, solve for the variable by using the multiplication property of inequalities, but again, be careful about multiplying by a negative quantity. Since the solution to an inequality is a range of values, you should check some test points in the original problem. Let's solve the inequality 5 plus 3x less than or equal to 17. There are no fractions, decimals, or parentheses to clear. When we subtract 5 from both sides, we get that 3x is less than or equal to 12. Then we multiply on both sides by 1/3. A positive 1/3 multiplied on both sides preserves the inequality, and we get that 3 over 3 times x is less than or equal to 12 over 3. This simplifies to x is less than or equal to 4. In this example, we've shown every tiny step for emphasis, but a formal solution could be as simple as the original inequality. Then, after subtracting 5 mentally on both sides, 3x is less than or equal to 12. And the multiplication of 1/3 on both sides produces x is less than or equal to 4. This solution also shows every step with the understanding that simple arithmetic is computed mentally. If it's apparent how one step follows directly from the previous step, then sufficient work has been shown. Now let's solve the inequality 2/3 x minus 7 greater than 1. We would add 7 to both sides, producing 2/3 x greater than 8. Then multiplication on both sides by a positive 3/2 maintains the inequality and yields that x is greater than 24/2, which simplifies to x greater than 12. We can complicate problems with more fractions. Solve the inequality 2/3 x minus 1/6 less than 2x. Not only do we have extra fractions in the problem, we also have x terms on both sides of the inequality. The least common denominator for all the fractions in the problem is 6, so if we multiply by 6 on both sides, we should clear out the fractions. After we distribute 6 on the left-hand side of the inequality, we get that 4x minus 1 is less than 12x. Notice that the fractions have been eliminated, which was our desire. Now we want to collect our x terms on one side, so subtraction of 4x on both sides of the inequality produces that -1 is less than 8x. Dividing on both sides by +8 produces -1/8 is less than x. Notice that we were dividing by a +8 or multiplying by a +1/8, which maintains the inequality. Rewriting, essentially for ease of reading the solution, we might write x is greater than -1/8. For one final example, let's solve the inequality 2 minus 3x greater than or equal to 14. We can subtract 2 from both sides, which produces -3x is greater than 12. Now we want to multiply on both sides by a -1/3, and when we multiply by a negative, the inequality sign reverses immediately in that step. Therefore, we get that x is less than or equal to -4.